Hey YouTubers, welcome to the Cyber Overwatch channel. I am Pragmatic1. In this video, I will be doing a walkthrough of TryHackMe's Brains vulnerable host. In this walkthrough, I'll cover the complete attack lifecycle, reconnaissance, enumeration, exploitation, and post-exploitation. Specifically, I'll perform port scanning, service enumeration, authentication bypass, remote code execution, and privilege escalation. If you find this content informative and you are interested in cybersecurity, please like and subscribe to the Cyber Overwatch channel. Also, for more free content, please regularly check back on www.cybersec.com. Brains is a vulnerable host created by TryHackMe. It's designed to simulate security weaknesses and give you hands-on practice with common attack vectors. The host demonstrates several critical vulnerabilities. Let's break down the attack surface using MITRE ATT&CK framework. TA0001 initial access. T1190 exploit public-facing application. The vulnerable TeamCity server exposed on port 50000 can be exploited by attackers to bypass authentication and gain initial access without credentials. TA0003 persistence. T1136.001 create account. Attackers can create backdoor administrator accounts on the server after exploiting the authentication bypass vulnerability. T1505.003 server software component web shell. Malicious JSP web shells can be uploaded to the team server to maintain persistent access and execute commands. TA0004 privilege escalation. T1068 exploitation for privilege escalation. The CVE 2024-27198 vulnerability allows unauthenticated attackers to gain administrative control and full privileges over the TeamCity server. TA0002 execution. T1203 exploitation for client execution. The authentication bypass vulnerability can be leveraged for unauthenticated remote execution on the vulnerable server. T1059.007 command and scripting interpreter JavaScript JSP. JSP shells are used to execute arbitrary commands on the compromised system. The Brains vulnerable host has been deployed and assigned an IP address, visible on the TryHackMe dashboard. The first phase of any penetration test is reconnaissance. The first objective is to identify running services, their versions, and potential attack surfaces. Nmap is my go-to for this phase. It's the industry standard for network discovery and security auditing. I'll execute the following commands shown in the CLI to kick off the initial scan. Since I have broken down this command in my previous videos, I'll just skip it. Feel free to look at my previous videos if you want a better understanding of what the Nmap flags do. The Nmap scan has been completed and I've got some interesting results. 4 ports are open. Port 22 SSH. This is the secure shell service for remote administration. OpenSSH 8.2p1 is fairly recent and it doesn't have any critical public exploits, so this probably isn't my entry point. Port 80 HTTP. The web server is running Apache version 2.4.41. The scan shows that the page displays maintenance in the title. Port 37263 HTTP Java-RMI. Java remote method invocation is running on this port, suggesting Java-based applications are present on the system. Port 5000 HTTP IBM-DB2. The service detection initially identifies this as IBM DB2, though further enumeration will reveal the actual service running here. The OS detection confirms that this is a Linux system based on the CPE data, and if I look at the service banners, it notes Ubuntu. When I navigate to the target IP on port 80, it displays a maintenance page with no interactive elements or obvious functionality. I examined the page source for comments, hidden fields, or exposed sensitive information. Unfortunately, nothing of value was discovered in the HTML source code. Attempting to connect to port 34197 resulted in a connection reset, indicating that the service may be firewalled or not actively listening. Port 50000 presents a TeamCity login interface, which is significantly more interesting than a static maintenance page on port 80. TeamCity is a continuous integration and continuous deployment server developed by JetBrains. It's a tool that helps software development teams automate their build, test, and deployment processes. Here's what it does. Core functionality: TeamCity monitors your code repository and automatically triggers builds when developers commit changes. It compiles code, runs automated tests, and can deploy applications to various environments. Key capabilities: it supports numerous programming languages and build tools, integrates with popular version control systems like Git and SVN, and provides detailed reporting on build status and test results. Teams can configure complex build pipelines with dependencies between different stages. Benefits: the platform helps catch bugs early by running tests automatically, ensures code quality through consistent build processes, and speeds up delivery by automating repetitive tasks. It also provides visibility into build processes through its web interface, where teams can see build history, logs, and metrics. Architecture. TeamCity operates with a server that manages builds and agents, separate machines, that execute the actual build tasks, allowing for distributed and parallel processing. A search for TeamCity 2023.11.3 vulnerabilities returns several results, including security advisories and proof-of-concept exploits. In the Google results, I clicked the vicarious.io web link. The vicarious.io write-up provides comprehensive technical details about CVE-2024-27198, including the vulnerability mechanics and exploitation methodology. This is an excellent resource for understanding the authentication bypass vulnerability. I highly recommend reading this analysis to understand the underlying security flaw. The write-up references a GitHub repository containing a working exploit. I navigated there to obtain the proof of concept code. To download the exploit, I'll clone the repository using the provided URL as shown on the screen. Executing this git command successfully downloads the exploit code to my local system, as can be seen from the output in the CLI. After reviewing the exploit code and the README documentation, I wanted to verify that all required Python dependencies are installed. I ran the following pip3 command. As can be seen from the output, the necessary libraries have been installed successfully. I ran the following Python 3 command shown in the CLI to execute the exploit. Based on the output, it appears I have obtained my initial access. The exploit performs several actions. Creates a backdoor user account, in this case added username LWRQ2T7J with the password of C, X, 3, lowercase z, lowercase k, uppercase u, uppercase z, lowercase I, uppercase s, lowercase b, giving the user ID of 11. 2. It identifies the target. The detected version of TeamCity, version 2023.11.3 build 147512 on Linux. 3. It adapts the attack method. Since this version patched one attack vector /app/rest/debug/processes, the exploit switched to uploading a malicious plugin instead. 4. Deployed a web shell. The exploit uploaded and activated a plugin called lowercase l, lowercase b, lowercase o, capital F, lowercase d, lowercase v, capital T, capital U, containing a Behinder.3.0 web shell, a tool for remote server control. Number 5. Achieved remote access. The web shell is now accessible at the URL shown, allowing the attacker to execute arbitrary commands on the compromised server. With initial access established, the next phase is host enumeration to identify sensitive data and potential privilege escalation vectors. I ran the following commands shown in the CLI to determine what folder I'm in and to view the contents. Based on the output, I am in the TeamCity application directory. One command I want to run immediately is sudo-l. This command checks what programs the current user can execute with elevated privileges. The output reveals that the Ubuntu user can run any command as root without password authentication, a significant security misconfiguration. During testing, I was able to determine that the web shell appears to have directory traversal restrictions, preventing direct navigation. I was able to run the ls-la command shown in the CLI to view the contents of the Ubuntu user's home directory. Based on the contents, I can see the flag.txt file. Reviewing task 1 on TryHackMe confirms there is only one flag to capture for this challenge. To be thorough, I ran the sudo ls-la/root command and verified that the root user's home directory does not contain an additional flag. After confirming there were no root flag, I ran the following cat command to view the contents of the flag.txt file, and with that I have completed the host. Thank you for watching this demonstration of the TryHackMe Brains vulnerable host. I successfully progressed through the attack lifecycle, performing reconnaissance, enumeration, exploitation, and post-exploitation. Thank you also for checking out the Cyber Overwatch channel. If you find this content informative and you are interested in cybersecurity, please like and subscribe to the Cyber Overwatch channel. If you have any questions, please feel free to leave a question in the comments, or you can send me a message from the CyberSec website listed in the description. Until next time, keep learning. The only way to improve is to keep learning. Pragmatic One, signing off.